So now for part 2, question 14 of the 2013 Zone A paper. You have this following question. Okay, read the description, and then let's move on to the first part. So now this is a simple question, gives you 6 marks. Okay, so you just need to write down the lifetime budget constraint and then interpret the equation, draw a diagram, and tell them how you find the optimal consumption plan. So this is our equation. Should be very clear to you now. If not, go and read up. Okay, so we have present consumption, discounted future consumption by your real interest rate, present income, and discounting with respect to current interest rates. So this is just a very simple 2-period model. So you can extend it all the way up to like 5 periods or 10 periods if you want, but it's not needed. Okay, so if you extend it further, just you add brackets, then you add square, cube, and so on. So how do you get that? So first we have this savings. Whatever you earn and you don't consume, you have to save. Okay? And then what you can consume in your next period, which is the period when you're going to die, is whatever income you earn when you're old and the savings you have multiplied by the interest paid. So by substituting the first equation into the second, we will get this magic. And so how do we find the optimal consumption plan? So we just need to plot out our budget constraint, which is the one we obtained previously, and then plot out our indifference curve, and then move the indifference curve only. So the budget constraint cannot move unless your income increases. So we move our indifference curve up, down, until we get a point where it is tangential to the budget constraint. So mathematically, how do we get this? So remember your slope of your indifference curve is called the marginal rate of substitution, right? So you just need to equate your marginal rate of substitution equals to negative 1 plus R, which is the relative cost of consuming in each period. So this is normally how you solve for optimum consumption bundle plan. So how you find C1 and how you find C2. Alright, we're done for this. Let's move on. Part B. They ask us to consider a situation where real interest rate rises. So that's our first thing. Okay, and then what's the effect of a higher interest rate on lifetime budget constraint? Simple. Okay, assuming individual is now a saver. Okay, use the diagram to deduce whether the rise in interest rates increases or decreases the saver's utility. So first thing, so when interest rate increases, budget constraint becomes steeper. So because the budget constraint pivots up, it must be that it increases the saver's utility. But how? So holding current consumption constant, increase in interest rate means that Y2 increases. Why will Y2 increase? Because C2 increases. And so, because C2 increases, utility increases. So it's like, when you are saving more because of the increase in interest rates. That's why you're able to spend more in your second period. And since utility consists of your current and future consumption, for a saver who saves, utility has to increase. Also, we should consider when an individual actually wants to borrow money instead of saving money. So will he ever find it optimal to do that? So look at this hypothetical indifference curve where it intersects at C1 prime. So this is obviously a lower indifference curve when he tries to move to a borrowing more money to consume more in the present period. So obviously the answer is no. Why? So when interest rate increases, right, no rational individual will want to increase their cost of borrowing. So for the substitution effect, so when current consumption is more costly than future consumption, any individual, Tom, Dick, or Harry, will reduce his current consumption. And now for the income effect, because for saver, his income depends on the future, because he's saving more. That's why his income, or rather consumption, we should say, depends on his interest rates. So since we know interest rate increases, income has to increase, and therefore he can increase his consumption. So this will increase his current consumption as well as future consumption. So borrowing to consume more would be highly unlikely unless we have this situation where income effect is larger than your substitution effect, and the saver is really, really, really near the point of inflection. So now he's at saver, and marginally he moves to becoming a borrower. So this is quite impossible. But, oh well, in economics, there's always a possible. Now, for part C. So in the newspaper report, these are the things that we need to take note of. Such a long question. So high interest rates, draw indifference curves, see whether a man is irrational by saving less when interest rate increases, explain answer in terms of income and substitution effects. So previously I mentioned a bit about income and substitution effects. And then lastly, we will close it by saying if all savers would be expected to behave in the same way.
Thanks for watching a sample of the Quickienomics online learning experience. We hope you've enjoyed it. We believe that true happiness lies in realizing ambitions and dreams. That's why we make our products specific to your needs, simple to understand and captivating, so that you can learn effectively while saving time, realizing those ambitions and dreams. The Quickienomics online learning experience is a range of supplementary lectures, tutorials, and exam solutions in the form of videos, which you can conveniently view anytime, anywhere. Watching our videos before and after your regular lessons at school, we aim to give you joy in learning and build academic confidence at the comfort of your own relaxed learning environment. So how can you begin? We welcome you to purchase $Quickie to redeem the videos for full access to the Quickienomics online learning experience. Thank you for studying with Quickienomics.